All right. Thank you, everybody, for coming in here. I know this is after lunch, so hopefully it was a good one and you've had your coffees. I definitely won't be putting you up to sleep, so it's a packed agenda. So I'm from Kasten. We focus on cloud-native data management, and we have a fairly packed agenda, so it's going to move fast. I'm going to talk about the context around backup and mobility. We actually have Michael, who's going to come in as a customer and talk about his journey, what it meant for him to be able to do backup and mobility. And finally, nothing is really true till you actually see it. So Webber and Michael will go ahead and actually show this to you. So let me just start off with, as a continuity, I think VMware Gopala did a good job talking about, trying to clear up some of the data management misconceptions. And I think the two key points to make out here is, first of all, having storage doing availability or replication is not the same as data protection, and he kind of outlined the reasons there. And then also, you need to you've heard this message throughout, but it's applications that you need to sort of look at when you're talking about the cloud-native data management, backup, and mobility. So what I'm going to do is, while Kasten, of course, works with VMware, I'm going to sort of take a step back and talk about what does really applications mean in this context, and talk about the two key requirements for both backup as well as mobility. So I think, first of all, just to clarify the stack, and if you haven't seen enough stack pictures today, you obviously have not been in this room, so this one I think is fairly simple, and really you start at the bottom. You always need to have some hardware to run your software on, and that's what you're actually seeing out there. On top of that, you typically have your block and file implementations, and those could be both on-premises, and there are obviously many vendors who play in that, as well as cloud vendors. And again, on top of that, you have databases or data services, and I think as an industry, we haven't quite settled on a common word for them, but these include both SQL, non-SQL, within that, whether it's streaming or whether it's graph databases, which under the covers obviously exercise block and file interfaces. But the stuff which is actually interesting is what I'm calling applications on top of it. So I think there was a slide before which talked about it's hard to think of an application which does not have state. And so while there are many different patterns of going ahead and talking about state, whether it lives in the same namespace or a different namespace, at the end of the day, each one of these applications is made up of multiple microservices. And in today's world, it's polyglot persistence, which means every microservice picks up whatever is their favorite database to solve that particular need that it was created in the first place to do. So it would either go ahead and exercise the underlying data service, or it can also directly go ahead and exercise the block and file system. So that's a fairly simple stack, and there's no reason to sort of really go ahead and make it more complicated than it needs to be. And that's really the point. But I think the two key points which Cloud Native brings in is essentially you need to be application consistent. And I think the panel before that did a good job talking about the pros and cons around what you get there, and I'll talk about that. And the second one is, in today's cloud-native world, you need to have the freedom of choice, and I'll tell you what that means too. So first of all, when it talks about, let's talk about backup for a second. So here, you need to sort of go ahead and have application consistency, and what I mean by that is, if you look at the same stack which I drew, and this is a simplified picture of that, everything in that dotted line is your application now, right? It has your Kubernetes cluster information, your config maps, your secrets, whatever the database or data service might be, and under the covers, your choice of storage system. So you could either go ahead and say, let me exercise the storage snapshot features, whether it's using CSI or whether it's using native. That's the second order conversation. The point to make out here is you need to have a storage system which supports that, and that's a crash consistent way of doing things. A second way of doing things is essentially you can go ahead and say, let me not necessarily have any thing inside the storage system. Let me go ahead and do it at the database level. And every database vendor has a choice of tools, whether it's a PG dump or whether you're doing some kind of log shipping, to go ahead and get a higher level of consistency. And you can also go ahead and do a backup by exercising those tools. And I think Aaron in the last talk talked about how do you get automation into the picture, and this is kind of what's being talked about in this context, which is at the end of the day, to really work in this environment at scale, You want to be able to go ahead and auto-discover all of these applications. You want to be able to go ahead and set the policies based on what the application's needs are, because not all applications and microservices are created equal, and now do they need to have the same level of backup in terms of availability and consistency and storage speed, et cetera. And so you want to go ahead and make sure that you have tools which can actually go ahead and do that in the best possible way and exercise the appropriate tool at either one of those layers which I talked about. And of course, you can mix and match. And then finally, because you have databases and there's no sort of stopping in terms of when that will end, so whether those are managed databases in the cloud or whether those are on-premises, the point is you want to go ahead and have a consistent way of being able to exercise and also customize when you want to acquire things. And Canister is an open source project which allows you to go ahead and get that extensibility. From a freedom of choice perspective, when you talk about mobility, I think there are many vectors to sort of think about that. The three key ones I want to just highlight before I let Michael come in is going to be you have different Kubernetes distributions, whether they are in the public cloud, whether it's an AKS or an EKS or a GKE, or whether it's on-premises, whether it's Rancher or whether it's Pivotal, Tanzu, as well as from a storage system perspective, like I said, there are block and file systems. Again, you have implementations of that both on the public cloud as well as you have them on premises. And then finally, other data stores. So we talk about databases, you talk about object stores, and this is, again, a very rich set of tools. So I think this is a growing universe, and I think from a data protection perspective, when we talk about mobility, you want to make sure you're not getting locked into any one of these things, and that's sort of really important from our perspective as a community part. So with that said, hopefully it gives you a bird's eye view of what the key needs are, but let me get Michael to actually talk about the pitfalls and the journey he took.
Okay, anybody can hear me? Yes? Okay. So I'm going to speak of our experience in our company about backing up. Because we had a hard time to find the right way to make backup, to make restoration. And then we suddenly found out that because we were working for government, we had the problem of sovereignty. And sovereignty was directly linked to mobility. So I'm going to explain that. So it's more like a journey in the sense of I'm going to explain all the things that fails for us, because we fail on many things. But at the end, fortunately, I think we found the right way to do that. So first, my company. My company is Soprasteria. It's like Accenture, if you knew Accenture, Capgemini, or Atos. We are doing about the same job. We're working for energy, we're working for government, we're working for direct end customer. And we were not using that much Kubernetes. It's just something like about 2 years that Kubernetes come into the scene. And we found out that actually Kubernetes is not only for startup company. Even big company like ours could really enjoy a Kubernetes structure. Because we have sometimes a very big park of application, and it's really hard to resuscitate them when we need to make some debugging. And Kubernetes is really good at that. If you need to resuscitate your application just to make your test and analyze, it's really easy to do that with Kubernetes. The second thing is the size matter. Yes, the size matter. I mean that when you have a big cluster, you make some very huge economy. And I'm speaking about money here. Building very little cluster is expensive, actually. So it's one thing we work on is doing very big cluster. It's very important for us to make big cluster. And of course, Kubernetes is bringing the usual advantage of Kubernetes, which is DevOps, because everything is as code. And beside, there was the opportunity to provide a unified way to build CI/CD in the company, because with something like 30,000 collaborators, something like 20,000 developers, was hard to have a unified way of doing CI/CD. Because Kubernetes was new, we could use this opportunity to make something more uniform. So now our customer quickly asks us the question, so okay, Kubernetes is nice, but how do you manage the backup? Because I'm not going to speak about that, but of course, we do stateful application. We are not stateless. And we could discuss that in a more longer way, but obviously we have built every database, every system in pods, in Kubernetes, so we are using stateful application. And the question is, how do you make backup? So to answer this question, you have to think about the requirements. First question is, what do you want to back up? The first thing you can do is the old way. You back up the bottom of the pyramid. I mean, all the file system, all the VMs, you back up everything. That's the old way. The second level of the pyramid is the etcd database, which is the definition of all the Kubernetes resource plus the definition of the cluster. Then comes the namespaced resources, and then the business data. So what do we want to back up? Do we want to back up the bottom of the pyramid or the top of the pyramid? And of course, the answer is backing up the bottom of the pyramid is not a good choice. It's too expensive, too difficult to reconstruct. I'm going to be more explicit on this. But what we want to back up is the top of the pyramid, the business data and the namespace resources. Beside that, we have some other requirements. First, we want to choose where we make the backup. Sometimes you want to use the EBS snapshot, which could be a good fit. But sometimes you want to save on S3. On some on-premise solution, you just want to back up on NFS. And so you have many, many places where you could make your backup. And whatever the solution you decide to build, you have to build a solution where you have the choice. And the second thing is, where do you rebuild your application? Where do you restore it? And sometimes the answer could be not necessary in the same cluster. It could be another cluster. And the last thing, which is very important, if you want to have the backup process successful, it must be easy. It must be easy to use it. It must be easy to operate it. It must not be too complicated. And we have a bunch of operators, people, and they don't want to make YAML most of the time. A little bit of YAML, but very little bit. Most of the time, they are more used to some tools like Vim. If people know Vims, it's a backup tool. And they want to work with a graphical user interface. They don't want to make kubectl, apply, and so on. So that was all our requirement. And with all that, it was difficult to find a good solution that fit all these requirements. So there is another point I was saying, which is today becoming the number one point, is the mobility. Why do we need mobility? First, for an obvious reason, the disaster recovery. The disaster recovery is directly linked to the mobility, the ability to move to another cluster, to another cloud provider. But we have also another requirement, which is the sovereignty. What does that mean? It means that we must have the control of where we decide to put our data. And because I know I am in USA, and I don't want to be negative around this great country, but in USA we have something called the Cloud Act, which means that even if you are in a data center operated by AWS in Paris, if the American government has an inquiry to get data, they can get the data. So it's very hard to explain to our customer, which are French government customer, okay, we are going to put your data in AWS, and until things are not getting wrong with USA, don't be worried. There won't be any problem. But if something is going wrong, we don't have the guarantee that something is not going to be disclosed by the need of an investigation, for instance. So it's very important for the forensic to be able to move whenever we want, whenever we feel that we should move. And of course, the last reason is the cost. Because there are many, many cloud providers now, and not only AWS, Google, and Azure. You want to be able to move, to choose the cloud provider which is going to bring you the best price. So mobility is also very important for that. So mobility is a topic, is a real topic that we must have in our mind when we choose the solution. So to the last point, the sovereignty, there is 2 points to manage that. The first one is to build your own data center. And we did that. We were working with a metal provider. We installed OpenStack on this. And once OpenStack was installed, then we start to install OpenShift on it and other Kubernetes cluster. And we had a complete control of where the data was, and there was no risk around the Cloud Act among the others. And that was working. But the thing is, this solution of building your own data center, your own Kubernetes service, is extremely expensive. It's extremely expensive and very hard to maintain. You have to get the right team for that, to have a very good team, and to be able to find enough customers to feed your infrastructure. Because once you build it, you have to get money back from the people who use that. So it's a hard fight. Another solution is to use the regular cloud provider on the market and to be able to move whenever you want. That's the other way you build the sovereignty. So just to come back to our first history on how did we build this tool system, the first thing we did was the more natural, the one that people were used to, was to build a backup solution based on the old way, which means backing up the bottom of the pyramid. But it was extremely expensive because we had to save all the VM. It was very hard to reconstruct because the number of nodes change constantly. The volumes are changing constantly. And the last point, which was really a blocking point, we are in a multi-tenant cluster. So if we decide to restore the Kubernetes cluster in one point in the time, we are putting everybody in the past. And that's a problem. Sometimes you just want to use point in time for one customer, not for all the customers. So this solution was not working very well. Then we moved to another solution because we were mainly using AWS. We start to use Lambda. So what did the Lambda do? Simple as that. It was working on all the EBS volume and make a snapshot of all of them. But this solution has also its limit. First, it only works on AWS, which is something that we're not very smart when you say it's very important to be mobile. So the second thing is we couldn't apply different policies. Some of the customers wanted to have a backup every week. Some of the customers wanted to have a backup every hour. So how do you make the difference with that? It's nearly impossible. Not so easy to reconstruct. I don't know if you have already, guys, experienced these things of building a new PVC, a new PV from an ABS snapshot. It's not so easy. You can't give that to a simple operator. It's quite hard, actually. Then we try something else, probably the worst solution we imagine. OK, you can laugh. I understand. We were doing a cron server with port forwarding, and we made all the backup stuff on it using the the primitive like pgdump, mongodump, and all that stuff. But the thing is, first, your cron server becomes POF, a single point of failure, which is a very big problem, and it often fails. The port forward is not stable at all. We experienced that. So sometimes the backup didn't work. And you have to share all the credentials. Because if you decide to back up a Postgre application, on the cron server, you have to bring back the credential of the Postgre. You don't have the choice. Otherwise, you can't make the backup. So this solution was not ideal. And finally, we tried that. The cron job. Everybody knows what's a cron job on Kubernetes. It's just the fact that you can run a job. So with this solution, you solve two problems. First, you don't have a single point of failure because the cron job is managed by Kubernetes. And the second thing is you don't have to share the secret between the database and the cron server because there is no more cron server. So that's cool. But that's not completely cool because when you make the backup, you have to back up all the data in a S3, for instance. And then if you want each team to be able to manage that properly, you have to give the credential to all the teams. And so we found ourselves in a situation where we were giving to something like 100 teams, about 100 teams, the same credential to the same S3 for the backup. And the other thing that I must say is that we have no monitoring. Sometimes things doesn't work and you have to build your own monitoring system. Most of the time you try to do that with Prometheus, but it's not easy. And you don't have any retention policy. Sometimes you want to keep a backup for once a month, once a year, once a week. So when you do that, it's hard to do that with a cron job. It's really hard. Not easy at least. Okay, so at the end, even if we try plenty of things, we didn't have a solution. We failed. And when I say we failed, we really failed on it. Because we had some case of some of the project just found out that the data protection was not working. And because they didn't check that the cron job was in a situation of failure, they didn't realize that they didn't have a backup of their database. So we had to fix that very quickly to solve the problem. But we had no monitoring and no retention. So I can say that we kind of failed on this. So after many studies, we found that the Kasten solution was the best one for this topic. For the mobility, for the retention policy, for the ability to give the tool to everybody easily. Because this is a very hot topic. Make the backup, make the retention, make the migration something easy. Easy for the operators team. We have something like nearly 2,000 people just working on operation in our company. And the levels are very, very different. So we need to provide a tool which is easy to manipulate. I must say that also we have kind of a certain turnover. And it's really hard to transfer the competencies for that. And we have the security, which is include. And the tools was first thought for Kubernetes. Kubernetes was the main target from the beginning. So all in all, this tool was fitting all our requirements. We are not blocked in a vendor lock-in, in a storage vendor lock-in. So for instance, we are able to save from EBS and then to restore in safe or in another storage system. It's possible. We are not tied to a storage provider. The last thing, and I think it's the last thing I must say, is actually the storage provider are not changing that much. You have Safe, you have EBS, Google Azure, Storage OS, few people in the market, so it doesn't change that much. But what is changing a lot is the requirement about migration, savings, and backup. And for example, that's a requirement that you quickly meet when you have a real customer, is how I can make a different retention policy depending on my application. Or how can I do, instead of an EBS snapshot, I prefer to make a MySQL dump. Is it easy to do with your tool? The last one, how can I move from a cluster to another one, which is a strong requirement, especially because we have customers who are on-premise. And the last one, being able to manage many vendors, and it's what we do. In our cluster, we use Safe, EBS, and we try some other storage providers sometimes. But we really work with these two. And this one is a use case that we are facing. We are using a big cluster on OpenShift 3, and we are going to move to OpenShift 4. And there is no upgrade in place possible with OpenShift 4. So we have to migrate the application one by one. So we need a tool efficient for that. That's another requirement. And another requirement is how can I integrate my storage requirement into my CI/CD? For instance, you start a test. You just want to make a backup of your database before running the test, so that at the next run, you can restore the database and run the test again. And all that is not so easy. And you want to integrate that in your CI/CD. So this is an example of what we notice is the storage provider are extremely stable, but the requirements around the data are very changing, always in movement. So I have finished this part, and we're going to...
Well, I think we're running out of time. What I'll do is, instead of doing the whole demo, I'm just going to set it up, and then we can do demos in the back if folks are interested. Would love to show them how Kasten works and what Michael talked about. Right?
That was too long.
That was perfect. That's I think, what we want to hear. So just to kind of set it up, this is what Kasten looks like when you install it in a cluster. We support a variety of Kubernetes distributions. When you're set up in a cluster, we go ahead and discover what are all your applications. Something that Michael was talking about is being aware of when things show up, when you aren't covered, when you don't have data protection.
This is especially true when you are in a multi-tenant cluster.
Yep.
You have plenty of customers that are bringing new application, and you don't realize that. They are not warning you. Oh, sorry.
No. Okay. And then I think the last thing I wanted to highlight was how we initiate, how you cover your application. So Michael talked about having an SLA, different customers, different requirements, and it's all policy-driven for us. So for example, if I wanted to ensure these applications were protected and were always protected, it's as simple as doing something like creating a policy where you can decide how often you want it to run, what kind of retention you want. Would you like just in-cluster availability, or you'd actually like it off-site to make it available, or for mobility, or just for disaster recovery? Being able to export to S3, for example.
And you can build a policy differently in whatever your application is.
Exactly. Depending on what your application is, you can have them very specific to an application or be very broad. So I can say everything, for example, that comes in with a specific label. Finally, I think the only thing I'll highlight here is everything in our system is all monitoring is through Prometheus. So all of this gets fed into Prometheus. You can set up alerts. All our APIs are Kubernetes APIs. So if you want to integrate into something like CI/CD or any other tool that knows Kubernetes, it's very straightforward.
So for the developer, it's easy to get back the YAML file and to integrate them in the CI/CD.
Exactly, when test restores or anything like that. And that's really all you need to do to make sure you're covered in your environments. Kasten will take care of all the execution, failure management, retention, all of that. Last one on this is you notice that I backed up MySQL over here, but I used 2 different mechanisms. So if you go ahead and look over here, the artifacts over here are not volume snapshots. In this case, I'm using an open source project called Canister, which we developed. It hooks into K10, and I've actually used MySQL dump to back up the data. I could use the same for some kind of managed service like RDS or something like that. The other backup I took, we actually took a volume snapshot, and we leveraged that to extract the data. I'll stop there. I know we went over time. Anybody wants to run through the extensive demos, we're happy to do that in the back.
Thank you. Thank you, Michael. Thank you, Team Kasten.
All right.
Thanks, Gaurav.